Okay, good morning everybody. Today I'll start a lecture on heat exchanges. So heat transfer already we discussed. Heat transfer means there are three modes of heat transfer: conduction, convection and radiation. Okay, you have seen this conduction when particles are resonating, it is not moving actually. Solid body heat transfer, normally it will be conduction, but convection normally it will be liquid or gas. So a particle actually will move from one point to another point. By radiation, you do not need any medium. For example, solar radiation coming to Earth, so it is not hitting the atmosphere, so it is hitting only directly to Earth. So, okay, so it is coming through certain media, but media is not being heated, or it can travel through. In radiation heat transfer, you do not need any medium, so directly it can energy can come from sun to earth actually. Okay, when it is passing through atmosphere also, it will not be heating up, but where conduction and convection, the medium will be heated up actually. So in conduction, especially solid body; convection, especially liquid or gas body, right? In liquid or gas also conduction possible, but convection may be more. So that's why normally we consider convection term. Okay, but in some cases we use conduction term also. For example, near wall heating. So there fluid movement will be very slow, very low. So in that case, actually molecular resonance will be affecting heat transfer. Okay. So heat exchangers are devices used to transfer heat from one fluid to another fluid. Okay, so one fluid to another fluid, and it will be separated by one solid medium. Okay, so for example, you have cold fluid, you have hot fluid, and one solid wall is there. So heat will be transferred from hot to cold. Okay, so then cold fluid temperature maybe will be increasing if it is not flowing. So slowly the temperature will be rising up, but hot fluid will be giving some energy to cold fluid. Okay. Uh, Typical heat exchanger experienced by us in our daily lives, including condensers, evaporator. If you go to your hostel or your mess, you will see refrigerator or fridge will be there, or air conditioner is there. In this room also air conditioner is there. So air conditioner, if you see properly, backside there will be some condenser coil like this. Okay, so condenser coil, that is also heat exchanger actually. Evaporator section in air conditioner or refrigerator, there is also some coil will be there like serpentine coil. Okay, so that coil will be used as a heat exchanger. Okay, from hot body to cold body heat will be transferred. There is a wide variety of heat exchanger for diverse kind of applications. Okay, one application is that refrigeration I already told. Engineering application, in industries also there, lots of applications are there. Okay, so in this picture you can see one heat exchanger. I have taken picture from this IQS directory. You see this heat is transferred from one pipes are there, and this whole system is called shell. Okay, and lots of small pipes or tubes are there. Okay, so tube will be carrying one fluid, whereas shell will be having another fluid, and heat will be transferred from shell to tube or tube to shell. Okay, later we will discuss in details about this phenomena. Now whenever talking about heat transfer, so you need one surface, solid surface, and one cold fluid will be there, or hot fluid will be there, and heat will be transferred hot to cold. Okay, when heat is getting transferred, you want solid medium, you need, let's say, copper or iron or some material will be there in between. So otherwise, if you do not have that solid material, then fluid will be mixing up. So mixing up, you may not allow many time. Okay, so if you are separating, isolating this hot and cold fluid, for example, oil and water, water is heating oil. So in that case, you are not trying to mix up oil and water. So in that case, you need solid boundary, okay, in between two. So heat will be transferred through that. So it must be high conductive material. Okay, high conduction should be there. And whenever heat is getting transferred and fluid is flowing, actually, if fluid, like say water or oil or gas, if they have some dust particle, if you have some calcium salt or other salts, then what will happen? Around the solid body, those will get deposited. Okay, when those are getting deposited, your heat transfer characteristic will change. In many cases, pipe can be blocked also. Okay, fluid is flowing through this one, and you are getting lots of deposition, upper and lower area, whole pipe area. So slowly this pipe will be restricted or constricted. Okay. For example, gas hydrate. If you have low temperature, the hydrate will be deposited inside a pipe. So that will be blocking the whole system. But if another thing is that if you have lots of dust or dirt particle, so that also will be deposited over this one. But if you have some chemical component also, that's also will be deposited on this surface. So when it is getting deposited, what is the problem? Problem is that it will be creating restriction of flow. Okay. Another thing is that heat transfer characteristic change. What is that? Let us say you are using copper pipe, it is very high conductive material. Now you have lots of dust over it, so dust will have low conductivity. Okay. So your intention is to give very high conductivity, but you got lots of dust and deposit on this one and fouling created. This is called fouling. Okay. So fouling created, that means it is not allowing to transfer heat. So you need more pumping power if it is restricted, or you need to heat more, you have to get more energy from fuel, because heat is not getting transferred actually. So if it is not getting transferred, then it will be wasted. Okay. So that means you should not allow this deposition of foreign material. Okay. So this is called fouling, this deposition. Okay. You see these definitions are there. Fouling, dirt film on the heat exchanger surface. Okay. So dirt film, that can be scaling, corrosion fouling, freezing fouling, biological fouling. So many types of fouling will be there. So all the deposition will be there on the surface. So this is negative. Okay. Scaling, most common form of fouling associated with the inverse solubility of salts. So salt will be soluble, but inverse means it is not soluble. So calcium carbonate, calcium sulfate, CaPO4 CaSiO, silicon oxide, calcium hydroxide, magnesium hydroxide, sodium, lithium. So all these salts will be deposited on the surface. Okay. So normally the boiler, thermal power plant people, the boiler application, what they will do, they will remove all the debris, salts, everything from water, then they will be using. First they will be removing all the salts, then they will be using for your heating purpose. Okay. Then if you do not have any extra salt or dirt, then there will be no deposition. Okay. But many cases it may not be possible. So in that case you have to remove this, you have to do cleaning operation, or you have to replace the whole system. Okay. Especially boiler, thermal power plant application, they will have feed water heater or feed water system. So feed water system, actually they will be removing all the salts and debris and all dirt particle. Then they will be putting into the boiler system. Boiler system means there is also heat exchanger is there. Boiler means water will be boiled. So that boiled water means that will be creating steam, high pressure, high temperature steam. So that will be passing through turbine and they will be extracting electrical energy. Okay. So in that case, because continuously they will be cooling and evaporating this water system, and feed water also will be coming. So feed water, if it is dirty, then scaling will be deposited, pipe can be blocked, and pipe blocked, and you are supplying constant heat, what will happen? Pressure will be increasing without limitation. So in that case, burst or accident can be possible. Okay, heat can be shooting up. Okay. So whenever you are using like high pressure system, so you will have pressure sensor, temperature sensor anyway. So in many cases sensor failure may be there, so accident can occur. But before that, you have precaution action is that you remove all the salt and dirt and use the water. Okay. But in oil, wellbore, whatever oil you are getting, in that case you may not be able to do that one. So in that case you have to observe whether salt deposition is happening or your hydrate formation is happening. If hydrate formation is happening, then you have to remove the cause, or you have to use line heater, so increase temperature of hydrate formation temperature, right? Or calcium or other salts are there, then again you have to observe it is there and it is getting deposited, then you have to remove time to time, or you have to remove the whole piping system altogether. Many times they will be doing pigging operation and other operation, pipeline engineering. Okay. So corrosion fouling will be there, caused by chemical reaction in the process stream. So if there is any corrosive fluid, let us say H2S or something, so this corrosion will be occurring. So corrosion occurring means the salt will be formed, salt will be getting deposited on the surface, metal surface. Maybe one portion will be removed and it will be deposited in another portion. That will also be dangerous, because whole system is designed uniformly. But because of corrosion, if it is getting uniform, heated somewhere, more heat somewhere, low heat somewhere, is somewhere blockage, somewhere no blockage. So that will be creating problem. And fluid flow, one property is you have to remember every time, that fluid wants to flow in smooth straight path. So if you are giving any restriction, it will be creating lots of turbulence, it can create erosion, erosion, cavitation. Okay, so that sort of issue will be coming. So if inside pipe if there is any debris or any salt formation or corrosion, anything is happening, then you have to observe that. Okay, observe means from outside you cannot observe, but you will have some measuring equipment or sensing equipment. Using that one you have to observe and you have to take action, because oil and gas industry, one small crack or anything can be disastrous. Okay. So freezing, fouling, freezing paraffin or other chemicals are there. So there's at low temperature those will be getting deposited on the pipe system. Okay, that will be blocking the flow system. Okay, that is also undesirable. Biological fouling, in many cases microbes and other biological growth will be there. So that will be blocking also flow path. Okay, so fouling, it will be narrowing down diameter, increasing pumping power because it is blocking. So you need more pumping power, electrical consumption more. So pump will be working more. Okay, so it will be consuming more electricity, then it will be pumping, because you are creating restriction. Okay, larger pipe means restriction will be lower, smaller pipe means restriction will be higher. Higher restriction means more pressure will be required to push the fluid through that restricted area. Thermal resistance will be increasing. Thermal resistance will be increasing means like deposition is there, their conductivity lower than actual metal conductivity. So it will be creating thermal resistance. Your purpose was to increase heat transfer rate, but this is not helping. Okay, this is opposing heat transfer. Then takes more heat to boil water or more cooling. Okay, so more heat means heat transfer not proper. Okay, so your target to reach certain amount of temperature, but heat is not getting transferred. So you have to give more fuel, because you are assuming there may be some other issues, and you are giving more fuel, more burning fuel, but you are getting less heat transfer. Okay, that will be one problem. Increase energy cost due to reduced efficiency. The system efficiency will be lower. Okay, so if fouling, you have to consider whenever any piping system is there. Okay, because oil and gas industry means lots of piping systems. So in piping system you have to check all these things. Actually fouling you have to check any erosion, corrosion is there, any dirt is getting deposited, any sand is getting deposited, if any hydrogen sulfide or other corrosive material is there. So again you have to check whether that is creating corrosion and creating fouling or any other leakage. Okay, so all these things you have to observe. Actually as a production engineer you have to keep in mind all these issues. Okay, when system is running smoothly, but suddenly you find some things is not working, maybe among these many of these reasons, one may be the reason, or maybe multiple of causes will be affecting things. Okay. Okay, single pass, multi pass, double pipe flow arrangement. So whenever you are talking a heat exchanger, normally it will be shell type, shell and tube type. Like one shell is here. Okay, and you can draw also if you like. One in, one out. So one in, one can be out. Okay, so one structure here, lots of pipes will be like this. Okay, you can draw like this. I can explain what is this one. Okay, so this whole body separator type big system is called shell. Okay, and these are tubes. Okay, and this is header, inlet. This is inlet, tube side inlet. Okay, and the tube side inlet, fluid will be collected here, then fluid will be entering here through this tube. Okay, then it will go this through this, the tube side exit. This is shell. So inside part is shell. Actually this part is shell. Okay, big pipe, and these are small tubes are there. I'll make a little bit different, just wait. I'll make like this. I'll make like this, so it will be better to understand. Okay, so like you see fluid will be entering here and it will be exiting here. Okay, so these are pipes. So this is single pass. Single pass means one time fluid entering and exiting. Okay, from left to right, entering and exiting. This is inlet header, inlet header, this is outlet header, and this is called shell. Okay, I have written already. This is called tube bundle, tube sheet, okay, and this is shell inlet, shell outlet. Okay, so shell fluid will be entering, then shell fluid will be going out. Okay, you see this. Okay, and there will be baffles. So baffles will be like this: vertical line, vertical line, vertical line, vertical line. So fluid will be entering here. It will go like this. It will go like this. It will go like this. Then okay, then it will go like this. It will exit. Okay, you see this, I have drawn line. Shell fluid will be entering and it will be going like this. Baffles will be increasing more turbulence. Okay, so when heat transfer rate, if you want to increase, you have to increase turbulence rate. Okay, if you have laminar flow will be creating two layer and will be passing smoothly, but there will be no mixing. But when you are creating turbulence, flow mixing will be happening. Low temperature and high temperature will be mixing more. When mixing more, it will be carrying more heat actually. Why turbulence? Like for example, I have one pipe, okay, and some fluid is touching here, and if it is laminar flow, this is high temperature maybe, okay. If it is laminar flow, so some laminar layer will be created and fluid will be smoothly passing. But if I create turbulence like this, so fluid will be mixing up. So hot fluid will be touching cold fluid will be touching heat. So heat will be exchange will be more. So heat exchange more means more heat transfer rate. Okay, so in heat exchanger actually you create turbulence, so that's why you create baffles. Okay, baffles will be giving more heat transfer rate. So this is single pass. Okay, now I'll try to create double pass, multi pass. Multi pass means how do we do? My pipe will be like this. Okay, maybe multiple arrangement will be like this. Okay, let's say fluid entering, fluid exiting through pipe. You see this. This is single pass, this one. Okay, and this is multi pass. Okay, multi pass means again I created a shell. Shell will have maybe like this: shell entry, shell exit maybe, and pipe in, pipe exit, exit of shell fluid, inlet of shell fluid, inlet of shell. Okay, so that way you are creating multiple pass. Okay, so you are creating longer flow path, so your heat transfer rate will be more. Okay, and double pipe flow. In double pipe flow, actually this side picture shows double pipe flow. How double pipe flow works? It will be like this. Now I have one pipe and this pipe is going like this. Okay, so fluid is entering and there will be something and fluid entering. Okay, shell in or outer pipe in. Okay, outer pipe inlet is here, outer pipe. So one pipe inside, outer pipe will be carrying different fluid with different temperature. Okay, and inner pipe is here. Inner pipe, let's say I am putting some dots so that it will be visible, more visible. Okay, this is inner pipe, and outer pipe you see this fluid is coming, mixing up, it is going like this, again going like this, going like this, and it is exiting. Okay, so two pipes you are creating. So and pipe flow direction I am showing like one bottom side sometime arrow, some upside arrow. There should be one in, one exit. So that will be parallel flow or counter flow. Based on that, the arrow direction will be changed. Okay, if I say parallel flow, then you see the top picture, it is showing fluid is going same direction. This is parallel flow actually. Okay, this single pass picture I have shown, you see this flow is in the same direction, this parallel flow actually, co-current flow. Okay, but if I change any shell inlet direction, so then it will be opposite flow or counter current flow. Fine. So there will be different types of heat exchanger, different combinations may be possible. One is that like single pass, multi pass, double pipe, maybe many other combinations also possible. Different company will make different arrangement to sell their product, and they will have some merit demerit also. They will try to make compact heat exchangers. So many places space will be on constant. So in that case they will be making compact heat transfer. Compact means low space will be required. Okay. Okay. So heat exchanger in facilities. So in oil and gas facilities, heat exchanger is shell and tube type most common. So this is shell and tube type whatever I have drawn, and left side picture also showing shell and tube type. One shell is there inside tube. Okay, this is called shell and tube type. So double pipe also may be there. So this one double pipe, the lower one DOUBLE pipe. Okay, so shell and tube type also will have different combinations. So double pipe is there. Plate and frame type is there, I am not showing that one. Bath type I will explain a little bit. Forced air, direct fired. So different other types also possible. So based on the company invention and many other requirement, they develop many types. So we are not going to discuss everything, that only few things we will try to discuss. Okay. Heat exchanger facility. Okay, heat exchanger facility like basically shell and tube type. Okay, a double pipe and bath type and many other types possible. Okay, and so bath type, if I see, bath type will have two type, direct, indirect. Okay, so in direct type what happens, heat source for bath heater can be coil of a hot medium of steam, waste heat, exhaust from engine or turbine. So that heat can be used in a direct heating system. So you have hot gas and directly you are heating oil or whatever you want to heat. For example, immersion heater, normally you may have used immersion heater, right? You immerse directly. So directly heating coil will be there, so that coil will be transferring heat to your water. Okay, so heat transfer directly to the oil bath. Okay, indirect type. In indirect type heater, actually you are using third fluid. Let's say you are heating something, water. So water will be passing to your oil system. Okay, so heat somewhere and you are heating somewhere actually. So and medium will be like water you are using as a medium. So okay, heat an intermediate fluid like water you are heating using for first heating, then trying to heat oil. Okay, instead of directly heating oil. So heat to an intermediate fluid, this gives heat to fluid. Okay, example, a line heater. Okay, line heater in a gas well stream to keep temperature more than hydrate formation temperature. Okay, fire tube heat, fire tube there also you can use water and then you are using heat to increase oil temperature. Okay, so baffles I told already, baffles. Where is baffles? Baffles is separately. Okay, so whenever you are buying shell and tube heat exchanger or any other type heat exchanger also, there will be tubular exchanger manufacturer association. They will have specification, they will nomenclature a specification, you have to follow their regulation. So I am not going to details of their rules and regulations, but you should remember that this organization will be standardizing things. Okay. So this is a shell and tube type, already I explained. This is a cylindrical vessel, it will have multiple pass of pipes. So single pass means one pipe is going through the system. Okay, so I will draw one simplest one, you will understand. This single pass, but if you want to make multiple pass, it will be like this. Okay, I have maybe okay, entering, exiting. Okay, and flow direction anyway you can change. It's based on parallel flow or counter flow. Okay, uh, tube side fluid is isolated from the shell side fluid. Okay, so in that case, many cases you will have some separating thing, so that upper pipe and lower pipe temperature should not be equal. Okay, common type heat exchanger used in production operation is tube and shell heat exchanger. Fine, and okay, now baffles. I'll go to baffles. Okay, baffles means like you are creating turbulence. So baffles, if I draw 3D picture, I'll draw like this. So baffles will be like 50%. Okay, if you see this picture, top one, baffles will be like 50-50 like this. I'll not looking good. Okay, so it is like this. So tube shell fluid will be creating lots of turbulence. So when it is creating turbulence, you are getting increased heat transfer. So baffle will not be complete circle, rather it will be cut in one portion, so that fluid can pass through this. Okay, so some will be like this, some will be like this. Okay, uh, and you will be creating lots of turbulence because of this one. And there will be tubing arrangement also. So square pitch tubing arrangement, like if you see this picture right side here, square pitch. Okay, 4 tubes are there, and in another case like triangular pitch, so here 3 tubes are there. So many other type of combination also possible. Okay, so just you should remember the different orientation or combination of tubing also possible. Okay, so heat exchanger tubes steel, it will be steel, copper, because copper will be having higher heat transfer rate, but steel will be little bit lower heat transfer rate, but strength, mechanical strength is higher. So many times steel will be used, but copper will be very high heat transfer rate, but strength wise lower than steel. Okay, so you have to compromise somewhere. Copper, steel, brass also can be used. 70-30 copper nickel alloy, 70% copper and 30% nickel. Okay, CuNi. Can be used. Aluminum also can be used. Aluminum very soft metal, but heat transfer rate is very high. Bronze also can be used. Thickness, whenever wall thickness you are talking about, so one term they use, Birmingham wear gauge, BWG. Okay, you should remember the term, BWG. Okay, Birmingham wear. Okay, so they use this unit for thickness measurement of tube. Sizing, whenever talking about sizing, again LMTD will be coming. With parallel flow, counter flow, when you are talking about shell and tube basically. So LMTD will be coming, but in LMTD you are talking about fixed length of tube, but many time multiple paths will be there. So to end, there will be certain portion you have to exclude from the system. So there will be one factor called LMTD factor. So normally like 0.95 or something will be multiplied. For example, LMTD you get let's say 50 degree, 50 degree Fahrenheit or centigrade, whatever. Because of this LMTD factor, actual temperature difference you have to consider lower. So if you are considering factor also, then we have to consider 95, then you have to multiply, then you have to use that value. Okay, if in problem I do not give any factor value, or if I ask you ignore, then no need to consider. But if I give the value, then you have to consider, otherwise your answer will be wrong. Okay, okay, then number of tubes. Number of tubes n, how many tubes will be required? So it will be like heat transfer rate divided by U, overall heat transfer coefficient, A, LMTD into L. Okay, so we'll solve some problems, so that time we'll see this all the units and everything. Okay, A means area, LMTD logarithm mean temperature difference. If we have consider factor, so you have to use with factor, then length of the tube. Okay, so that way you can calculate how many number of tubes will be required. Okay, A is tube external surface area. Tube external surface area uh, per feet of length. Okay, L is, okay, this one. L is length of the total pipe. So this can be coming from chart, if diameter is given, then you can calculate also.